Hello friends, in this tutorial you will learn how to create and set up Python VENV virtual environment on a Linux system. So in the first section, I will give a brief description of what is a VENV and how it is used on a Linux system. In the second section, we will learn to create a VENV virtual environment on a Linux system. Here we will be using the Ubuntu 25 version of the operating system. So then we will learn how to activate the virtual environment and how to deactivate the virtual environment on Linux system. We will also briefly explain how the virtual environment works on Linux and how it selects the Python interpreter. We will also learn how to solve the error like ensurepip is not installed. Now we will also install packages inside our VENV environment, and we will run Python scripts inside our VENV environment using the installed packages. We will also learn how to recreate the VENV on other machines using the requirements.txt file. Now let's start our tutorial, and you can find all the required information available online on our website. The link is in the description. So if you like our tutorial, do like and subscribe. It helps us a lot. Now I'll be using fast fetch right now to show that the operating system is Ubuntu, the latest one, 25.01 on x86 64-bit platform. Now I'm using VirtualBox here, and this is inside a VM. So here we are going to do Python development. So the first thing we have to do is to check whether Python is installed or not. You can use the where is command, and you have to type Python 3. So it will show the location of the Python. You can see that the executable is located at user bin Python 3, while the libraries are inside the userlib Python 3. So this is our system Python. Now if you just want to see where the binary is located, the executable, you can use the which command. So you can see that it is at user bin Python 3. So now we are going to create a VENV Python virtual environment on Linux. So for that we have to create first a folder for storing our Python source codes. So for that we can use the make-dir command to create a folder or a directory called as Python _venv _project. So I'm creating this inside my home directory. Now inside the Python VENV project directory, we will create a source code directory. So let's create that one. So this is the one. We will store all our source codes, that is the Python source codes, inside this particular directory. Now inside this particular directory, we will be creating our Python virtual environment using the VENV module. So you can type Python 3 -m VENV. This is the name of the module and the name of the virtual environment you want to create. So you can type it as VENV. So I'm giving the same name, VENV. This is the name of the virtual environment. You can also give any name if you want to. For example, if you want, you can give it myVENV also. So let's give it myVENV. So you're getting an error message saying that virtual environment was not created successfully because ensurepip is not available. So this particular package we have to install it. So you can just copy the option here, apt install Python 3.3 VENV. So this will automatically install the ensurepip. Then you have to use the sudo command, then you paste it here. So this will install ensurepip. So enter. You have to make sure that internet is connected. Press Y. Now we have installed the ensurepip. So I'll create the VENV inside this one. I'll just use the term VENV also. So I'll press enter. Now we have created the VENV virtual environment inside our directory. As you can see that there are two folders inside this particular Python VENV project directory. The first one is the source code directory and the other one is the VENV directory that we have created. So I'll go inside the VENV directory. So you can see that there are multiple folders: bin, include, lib64, and a configuration file. So these things provide the basis for your virtual environment. And I will explain all these folders now. And I will explain to you what a VENV Python virtual environment is. So this is basically a directory that we create so that we can do the software development piece without affecting the system Python installation. So it's basically a directory that will contain the Python interpreter Either it's a copy of a Python interpreter or a link to the system Python interpreter. It will also have a pip package manager. So that will be used for installing our packages locally. The packages will be installed inside the virtual environment. So there will be some activation scripts like this one, which is used to turn on and off the Python virtual environment. And all the packages that are installed locally will be inside this particular directory called as the local site -packages. So this is a simplified block diagram, and it's common for both Windows and Linux system. There are some differences between both of them, so I will show to you that one. By the way, this is our website, and we have an article on how to solve most of the problems that you encounter while installing a Python VENV environment on your system. So this is a simplified block diagram of how the Python and the virtual environment interact with this one. So this block diagram here represents the system Python environment that is coming by default. It's already installed on most Ubuntu based systems. You can find the particular Python system interpreter at this particular location. I have shown you before that you can use a which command or a where is command to find your system Python interpreter. So when all the libraries that are used by the system Python interpreter are usually stored in the system-wide Python libraries. So that will be inside something like user lib Python 3 distribution packages. So this may differ slightly between the different version of the Ubuntu. Most of this will be located at this particular location. So we have created a virtual environment. So this is the virtual environment we have just created. There is a small difference between the names of the virtual environment. I have used VEN. Here you can see it's my_VEN. Just ignore that one. So inside our particular directory, you will find these particular things. We will have a Python interpreter. That will basically a link to the system Python interpreter. We will be using the same Python interpreter that the Linux system is also using, but the rest of the things will be local. So when you are installing something, the packages will be installed in the local site packages. So it won't disturb this particular section, that is the system-wide Python libraries. Now if you look inside your virtual environment, in our case it is VENV. So you can go here, and this is the home Python VENV project. So inside the VENV folder, you can find multiple directories like bin, include, lib64, and pyvenv.cfg. This is the configuration file. See, all the important things that are used for activating and deactivating the Python environment are inside the bin folder. So as you can see, these Python 3 and Python 3.3 are symlinks to the system Python interpreter, and these are the pip executables that are used for installing the packages. And inside that you can find multiple activation scripts like activate, activate.csh, activate.fish, and activate.ps1. These are used to turn the virtual environment on and off. Now I have shown you what is inside the bin directory. This is a simplified tree diagram of the directory. Next one is the include one. This folder you generally don't use it because it is used for storing the C header files. So you can basically ignore that one. Next one is the lib directory that will contain something like the version of your Python. In my case, it is Python 3.3, and inside that directory, this is the name of the directory. There will be something called as site-packages. All the packages that you are installing using the pip are stored inside this particular directory. So it will come basically with pip and pip 25.1 dist-info. These things will be there by default. So when you create this environment, this will be done by the system itself during the creation. lib64 is basically a link to the lib library, so you can ignore that one. The other one is the python venv.configuration file. So inside ven, you can find the configuration file. If you want, you can open it with the text editor. So this is the home of the Python system interpreter. Home equal to user -bin, and you can see that include -system site packages equal to false. That means that we won't be using the packages installed on the system Python directory. This is the version of the Python and the executable. So this is just for the command that was used to create the environment. Normally you don't touch this particular configuration file. You can ignore it. I just want to tell you that. Now I'll stop the tour of the VENV environment and I'll go back to the command line. to use our Python VENV project, we have to activate it first. So to activate this, you have to call the activation script. So we'll be using the source command for running the activation script. So it will be source. So we are inside Python VENV project. So you have to give the path name to the activation script, venv hyphen the bin, then hyphen activate. So we have activated the project. If the name of my VENV environment is slightly different, for example, if it is my_venv, then you have to give that particular name here. Rest of the things the same. You don't have to particularly call the activate.sh1 or something like that. You can just call activate. It will automatically use the correct script. So once the script is activated, the prompt actually changes. You can see there is something called as VENV here. So this is the name of the folder. So if you have used a different name during the creation process of your virtual environment, it will be shown here. You can see that here I am using my_venv. This is the article from the website. So the prompt is also different. It's my_venv. So here we used venv, so it is venv. Now we are inside the virtual environment, and only those packages that are installed inside the virtual environment are available for us. So the default Python packages will be available, but others will not be available. So I'll use something called as which Python. So we are inside the environment, and this will show that which Python interpreter the system will be using. So I'll press that, and you can find that the location of the Python interpreter is home Rahul Python_venv project venv bin Python. So we are using the Python inside our venv environment. So I just call the Python 3 interpreter. So some of the system packages will not be available here. For example, PySerial is installed by default on the system, but inside the venv it's not there. So if I use this particular command, it won't work. After getting out of the venv environment, this command will work. So to get out of this particular venv environment, you can use the deactivated command. So just press deactivate, and we are out of the venv environment. So you can see that the prompt has changed. That means that we are out of the venv project, a venv environment. I'll call the Python again, and I'll use the import serial command here, and you will see that it will work. There won't be any error because by default it is installed inside the system Python. And since we are outside this one, we can check the. You can see that we are using the system Python now. This is how you activate and deactivate the Python virtual environment. Now we will tell you how the activation script works on Linux. So we'll be using the source command to run the activation script. So when you are running this source command, it will use one of the bash script inside this particular folder, and it will change the path environment variable so that the local Python, that is the Python inside our virtual environment, is the first entry inside the path variable. So the reason we are using source is that we want to make sure that all the changes that are made by the script remains inside the current shell. So if you use other way to activate it, it will create a separate shell, and the changes will not be saved in our current shell. You can also use dot here. This means to run the activation script in the current shell and do not create a new shell for running the activation script. So I can echo the path variable right now. So I run the path variable here, and you can see that the first entry in the path variable is the location of our local Python interpreter. So when the operating system searches for the Python interpreter, it will use the first one. So that will be this one. So you can check it using the which command also. So we know that the executable is this one. So this is the one we will be using. So we can use the deactivate command to exit from the virtual environment. So deactivate is actually a function that is loaded into the memory of this current shell by the activation script. So you don't need to use any dot or source or anything like that. It will work similar to the system bash commands. So you can just type deactivate. Now if you check for the path variable, it will be different. Everything has returned back to the system. So use the which Python also, it will Earlier we used to install Python modules using this particular command, Python 3 -m pip install ttk bootstrap. But in newer version of Ubuntu and other Linux distribution, this is not allowed. It is not recommended to install modules directly into the system libraries. So we will be installing all the packages locally into our Python VENV project libraries folders. So we will not be touching the system folder. So to install packages locally, you have to first activate the VENV environment. So you'll be using the .ven bin activate or source ven bin activate. So I'll just activate this particular one, and then I will install ttk bootstrap inside our virtual environment. So you'll just press enter. So this ttk bootstrap will be installed inside the lib python then site-packages folder. So you can see that inside that one also. So it will also install pillow. So I'll just go here and I will go to ven. This is our Python VENV project, and inside that there is this ven folder, and inside lib python 3.13 site-packages you can find the pillow libraries, pillow, and the ttk bootstrap libraries. These are all installed locally, so this is not available outside our virtual environment. So you can also install something like PySerial also. So I'll do that again. This also will be installed locally. You can find the serial here, PySerial, serial. These are now installed locally. This is the location. Now that we have installed the packages, we will run some code also. So for that, we'll go inside the source code, and you can use some text editor like Nano and create a Python file, test.py. So you can write something like import serial. Then you can exit from here, Control X, and save modify buffer. Press Y. So we have the test.py here. Now I'll run it, Python or Python 3. There is no difference. It will use the same thing. So it will be src-test.py. So it has printed this particular command. I have not connected any particular serial port into this one. So it just gave the default information regarding the serial port. So this is running inside the virtual environment. Now that we have installed various packages inside our VENV environment, we want to get a list of all the installed packages. So for that, you can use the pip freeze command. So before running the pip freeze command, you have to activate the virtual environment. So you can do it. Now you can run the pip freeze command. It will display all the installed packages inside our virtual environment. So you can see that we have installed all these things. Now let's say somebody want to recreate this particular virtual environment and want to install all these things. So we can create a requirements.txt file which the other person can use to recreate a virtual environment similar to the one we have. So you can use the pip freeze command again, and then you can redirect the output to a text file. So we'll name it as requirements.txt. So all the information that is listed by the pip freeze will now be available inside this particular text file. Now you can go inside the file system, and you can find that there is a file called requirements.txt. So we'll open with the text editor. Then you can see the same things that are displayed by the pip freeze command. Now somebody else can use this requirements.txt to create their own virtual environment similar to the one we have. So I'll close it again. Then I'll deactivate the virtual environment and create another one. So we'll create another virtual environment named other Python VENV. So we'll press enter. So we are inside a different directory that does not have a VENV. So we can check that there is nothing inside this one. So we will create another VENV inside this one. So we have created another VENV environment. Now we will activate this one. So you can do the activate script source. Then we will check what all things are installed inside this virtual environment. So you can use the pip freeze command again. So it will say nothing is installed on this one. We need to install all the packages that were there in our previous environment. So you can go to the file system, and from there you can copy the requirements.txt file and copy it. Then you can place inside the other Python VENV, paste. Then you can install this one, install -r requirements, or the name of the file. So this will install all the packages that were there in our previous one. So we can see that the command has installed all the packages that were present inside the requirements.txt file. So you can check it again, pip freeze. So we have all these commands. We have all these packages installed in our other Python_VENV environment. If you want, you can check the library also. Now we have two similar VENV environments. Now you should deactivate this one. You need to make sure that the environment is activated before running the pip freeze command. Now you have a website also. You can find the link to that particular website on the description of this video. This will list all the required commands and also a textual description of the whole tutorial. We also have a Windows section for this also. How to install VENV on Windows also. You can check it out if you want to. If you like our tutorial, do like and subscribe on our YouTube channel. Thank you for watching this one.